Welcome to today's Explainer. Today, we're diving into a genuinely fascinating piece of engineering that is completely flipping the script on heating, cooling, and commercial real estate. We're looking at the ultimate investor pitch for FCH HVAC. Or, to keep things simple, we'll just call it FCH from here on out. This isn't just some tiny, incremental tweak to your standard air conditioning. Based on the hard engineering data we have, this is a massive, fundamental shift in how we power our largest buildings. Let's get right into it.
So, imagine you're sitting on a corporate board, or maybe you're a developer planning a huge new hospital, a sprawling logistics hub, or a massive shopping mall. You're dealing with two massive headaches right now, right? First, volatile, skyrocketing energy costs, and second, those strict ESG mandates demanding major cuts in carbon emissions. The big question we're tackling today is this: how do you cut these HVAC operating costs by a massive 50% slash emissions and secure total energy independence, all without making huge compromises? While the source material we're analyzing today points to a solution that honestly sounds a bit like science fiction at first, but it is deeply grounded in basic geology. The answer? It's already waiting right beneath our feet. The Earth itself acts as this infinite, completely free thermal battery. Instead of generating all our heating and cooling from scratch using crazy amounts of grid electricity, what if we just tapped into the massive, perfectly stable energy reservoir that nature already built for us? Here is our roadmap for today's Explainer. 1. Inexhaustible free energy source. 2. Unique direct transfer tech. 3. Magic of numbers for heating and cooling. 4. FCH versus traditional heat pumps. 5. ESG and unbeatable efficiency. And finally, 6. Polish know-how and global security.
Section 1. Inexhaustible free energy source.
The fundamental scientific truth driving the FCH system is just brilliantly simple. Think about solar or wind power. They're great, but they're incredibly volatile because they depend entirely on the weather. Groundwater, on the other hand, offers absolute temperature stability. It literally doesn't matter if there's a blizzard raging outside or a scorching summer heat wave. The Earth's groundwater is a massive, stable energy reservoir, maintaining around plus 10 degrees Celsius 24 hours a day, 7 days a week, pretty much anywhere.
And the visual proof of that stability is pretty striking. If we look at the temperature distribution data, the summer and winter temperatures swing wildly near the surface. But as you go down, they quickly converge. By the time you hit just 10 meters deep, the temperature flatlines at a perfectly stable 10 degrees Celsius. That 10-degree baseline is the absolute secret weapon here. It's an untapped, inexhaustible battery, just waiting to be plugged into.
Section 2. Unique direct transfer technology.
Now, this is where the engineering gets incredibly elegant. The FCH system relies on a globally unique direct transfer mechanism. Step 1, they use highly conductive, acid-proof steel heat exchangers placed straight into that stable groundwater. Step 2, a totally safe, environmentally friendly 35% glycol solution circulates through those exchangers, picking up that perfect 10-degree temp. Step 3, and this is the absolute game changer, that energy is fed directly into the building's air handling unit. No energy-hungry, noisy compressors in the middle, just a simple circulation pump doing all the heavy lifting. It is virtually frictionless energy transfer.
Section 3. Magic of numbers, heating and cooling.
All right, let's put some numbers to this. Picture the dead of winter. It is a freezing minus 20 degrees Celsius outside. Traditionally, heating that air to room temperature takes massive amounts of gas or grid electricity. But with FCH, that minus 20-degree air is preheated by the 10-degree groundwater just running through the coils. That brings the air up to about plus 8 degrees, completely for free. Then it passes through a standard rotary heat recovery wheel, and bam, the system delivers fresh air at plus 17 degrees Celsius. You just went from minus 20 to plus 17 with absolutely zero extra heating energy from the grid. Pure ecological magic.
And summer? The cooling performance is just as wild. Imagine a brutal heat wave, plus 35 degrees outside. The FCH system just runs that cool 10-degree groundwater energy through the air handling unit. It effortlessly cools that sweltering outside air down to between 16 and 18 degrees Celsius, again, completely for free. So during peak summer, when traditional AC grids are browning out and power prices are skyrocketing, an FCH building only needs a tiny sip of energy just to fine-tune that final temperature.
Section 4. FCH versus traditional heat pumps. Let's do a ruthless, head-to-head comparison with traditional heat pumps. Look at the materials first. Traditional systems use plastic pipes, and plastic is literally an insulator. FCH uses acid-proof steel, which is an incredible thermal conductor. Because of this massive difference in conductivity, traditional heat pumps have to drill crazy deep boreholes, like 150 to 200 meters down, just to scrape together 4 kilowatts of power per hole. FCH, they only need to drill 20 to 40 meters into the groundwater zone. Thanks to that steel, they pull an astounding 10 kilowatts per borehole. Shallower drilling, superior materials, and zero internal heat pumps mean the initial capital expenditure, the CapEx, for FCH is significantly lower than traditional geothermal systems.
Section 5. ESG and unbeatable efficiency.
Okay, look at this staggering number. In the HVAC world, efficiency is measured by COP, the coefficient of performance. A standard, really high-end traditional heat pump might brag about a COP of 4. That means 4 units of heating or cooling for every 1 unit of electricity used. Because FCH is completely passive and only uses small circulation pumps, its cooling COP can reach an unprecedented 1 to 40. It just absolutely obliterates standard industry benchmarks.
When you translate that COP into actual facility metrics, the ESG victories are just undeniable. Our data shows FCH reduces overall HVAC energy use by at least 50%. It slashes CO2 emissions by a massive 70%. Plus, since it relies entirely on water and safe glycol, there are 0 harmful F-gases or freons anywhere in the system. It is arguably the most ecological renewable technology on the market today, and it simultaneously drives massive operational savings. You are literally saving the planet and your bottom line at the exact same time.
Section 6. Polish know-how and global security.
Now you might be thinking, is this just a prototype? Not at all. FCH is 100% patented Polish technology, and it's highly mature. We're talking proven installations across more than 100,000 square meters of commercial facilities. And in today's era of global supply chain nightmares, FCH offers incredible resilience. Why? Because there are no complex compressors or rare microchips needed for the core energy transfer. On top of that, the creators offer full project design support and have partnered with major recognized manufacturers like Cleanmore, VTS, and VBW to build the air handling units. It's totally scalable. Just to anchor this firmly in reality, we can look at official reference letters from massive commercial players like Carrefour. Over a decade of successful deployments in vast commercial spaces, we're talking shopping malls, hotels, hospitals, proves this is a completely de-risked investment. The technology works, it saves a fortune, and it scales seamlessly to the largest buildings we can construct.
Which brings us to our final thought today. The data is incredibly compelling. FCH isn't just some nice upgrade to your air conditioning. By tapping directly into the Earth's infinite thermal battery, slashing your CapEx and OpEx, and ditching complex machinery, it really stands as the ultimate engineering answer to the energy and climate challenges of the 21st century. The question isn't whether you can afford to implement FCH in your next major development. In today's crazy energy landscape, the real question is, can you afford not to? Thanks so much for joining me for this explainer, and I really hope this sparks some brilliant ideas for your future projects.